Hey guys, hope you had a good weekend. We're going to jump right back into some more log stuff. But before we do the lesson, I just wanted to check in and say if you did not submit, remember you only have to submit the homework sheet, not the lesson sheet. You can do the lesson sheet on your own pace. Remember, open up your phone, play the video, go into the lesson, fill in as much as you need. Once you understand it, go ahead and do the homework. Okay? So today we're going to get into solving word problems using logs, and there's going to be some loop back into last chapter with exponentials. We'll see that in a second. So let's get started with the first problem that says Ryan's parents give him $5,000 to invest. Right, that's his initial amount for his 16th birthday, and he will be investing in a bank that will pay him 4.6% compounded quarterly. That's not a highlighter. Quarterly, okay? And they give you the function. So recall this function, initial amount, 1 plus the rate over the number of times compounded to the t times the number of times compounded. This represents the amount after t years. So it says algebraically determine to the nearest tenth of a year, right, tenth, how long it would take to double Ryan's investment. Well, first off, what does double Ryan's investment mean? Well, if he had $5,000, that means 10,000. So we want the amount after a certain amount of time to be 10,000. So I'm going to say 10,000 equals 5,000 times 1 plus 0.046 over 4 to the 4t. Okay, so we want to solve this algebraically for t. So basically, we're going to use logs. Anytime you have a variable in the exponent, convert to a log, solve using logs. So first, let's get the term alone. So I'm going to divide this whole side by 5,000. And you get 10,000 divided by 5,000 is 2 equals parentheses 1 plus 0.046 to the over 4 to the 4t. Okay, so now that we've got it alone, well, the first thing, I'm actually going to take what's inside here and simplify it. So I'm going to check out what that is. 1 plus 0.046 divided by 4. Okay, so I'm going to change this to 2 equals, I don't need parentheses anymore, 1.0115 to the 4t. Now, recall from Friday, or from last week, when we take something that is exponential and we get it into logarithmic, we use log, I like to call it BAE. Base, answer, exponent. So everything here, when we convert to log, goes in that spot. So the easiest is the exponent. So this is the exponent, right? This is the base. It's what's being raised to the exponent, and the answer is what it equals. So now when we convert this, it becomes log, and this is weird, but it's still fine. 1.0115 is the base. The answer is 2, and that will equal 4t. So now this left side is just a value. Log base 1.0115 to the second of 2 equals 4t. Well, this is just a value. It's saying 1.0115 to what power is 2. So let's do it. So we could do that in the calculator, or we could divide by 4 now and get t alone. It doesn't matter. I'm going to actually take the calculator, and I'm going to do, log base, what was that number? 1.0115 of 2. And I got this number 60.619580099, that whole thing. Okay? Now, that's that value there. I'm going to take this and divide by 4 to solve for t, the amount of time it would take. Now, remember, we have this now in our calculator, the answer button, so I'm just going to put that answer divided by 4. And there you go. We get t equals 15.15 to the nearest tenth, it said. Don't forget, 15.2 years. So it would take 15.2 years for him to make his $5,000 investment $10,000. Okay. Now, be careful. The only thing I'm thinking is maybe it'll say how old would he be to the nearest year or something like that. That could be a different question. That's not what this is asking, but you could do that. Okay, so one more problem, and then I'll let you guys get to the work. Maria wants to start a college fund for her daughter, Lucy. She puts $63,000 into an account that grows at a rate of 2.55% per year, compounded monthly, right? So monthly is 12. Write a function c of t that represents the amount of money after t years after the account is opened if no more money is deposited or withdrawn. So c of t equals 63,000, parentheses, 1 plus, since it's growth, 0.0255 over 12 to the 12t. Okay, and now calculate algebraically how long it will take for that account to become from originally 63,000 to 100,000 to the nearest hundredth of a year. So we want the amount of money after t years to be 100,000 equals 63,000, parentheses, and I'm just going to simplify this to make our lives easier again. What is 1 plus 0.0225 divided by 12? Okay, so I'm going to write this as 63,000, 1.001875 to the 12t. Great, so before we want to convert this to logarithmic, let's convert it, I'm sorry, not convert, but let's isolate that variable. And remember, how do I know I'm going to convert this to logarithmic? If you're solving for a variable as an exponent, you want to use logs. This is not going to be a pretty number. Let's see. 100,000 divided by 63,000. Yeah, that's kind of gross, but that's okay. 1.58730187. That's enough. And remember, it doesn't matter how many decimals we really write over here. Write enough, but you're just going to use this anyway, so just don't even stress about it. So equals 1.001875 to the 12t. And again, now that we have it isolated, base, exponent, answer, log bay. So log base 1.001875, answer of 1.58730187 equals 12t. So let's solve it. We get log base 1.001875 of, and I think I could just hit answer here. That'd be great. Yep. We take that, and we're going to divide that whole thing, which is this number. Remember, I just don't want to write it. I'm trying to save myself time. 246.649857, on and on and on. So I'm just going to divide that number by 12. So answer divided by 12, and there you go. Time equals 20.554, which to the nearest hundredth is 20.55 years. Okay, so that is the lesson, and you guys can now try the worksheet and submit it by Monday at 3 o'clock. Again, for now, just try to do it by 3 o'clock. Eventually, I'm not sure if they want us to keep with that, but for now, let's do that, okay? So any questions, just send me an email or send me a message on Classroom, whatever you may want to do, and good luck.